Good morning, everyone. My name is Lucian Pullen, and I will be your tutorial for today. Okay, now today we're going to be doing tutorial 5, which is based on linear momentum and collisions and rotation about a fixed axis. Let me just go to my actual questions. I will be doing from Arnold should have done 1 to 5. I'm going to start doing it from number 6. Okay, so the first problem, let me just see if I can enlarge it so that everyone can see. Okay, there we go. This is as big as it gets. It's question 6. Let me just see how it is. Okay, everyone can see it nicely. Okay, now the question is, just see if it shows up there. Yes, it does. Beautiful. Okay, like I said, we're going to do linear momentum and impulse, and then rotation about a fixed axis will most likely be done by James. Okay, Dr. Jenna. Okay, now the question is a zero point 0.2 kilogram stone you throw, so you're throwing a stone and it rises 34.3 meters in the air. Okay, so you throw a stone upwards, it rises 34.3 meters in the air. Okay, the magnitude of the impulse the stone received from your hand while being thrown is. So first of all, what is impulse? Okay, what is impulse? Impulse is equal to the force with which you move something and the time over which that force acts. So impulse is force times the change in time. Okay. Now we want the force but there is another formula for impulse. Impulse is also equal to the mass times the change in the velocity. Okay? Mass times the change in velocity, that is also impulse. Okay, now I'm not going to derive that formula. It should be quite easy to see how you get that formula. uh, let me see if I can do it quickly. We know that force is equal to mass times acceleration. Okay, and then if we expand that, let me just write it here. Mass times acceleration, we have mass. We know that acceleration is the change in velocity over the change in time. Now this is Newton's second law. Now if you plug it in here, if you were to substitute this force here, this is force, for Newton's second law, you'll find that the time cancels, leaving you with mass times the change in velocity. Okay, so it's not a difficult derivation, but it is that nonetheless. So now we've established that impulse is also mass times the change in the velocity. Okay, now do we know what the velocity initial is? Okay, we do. It's 0. Okay, it was initial in your hand and then it was thrown upwards, so v initial is 0, while v final is what we want. But we have the distance that it is thrown, so we have x, and this is what we want. We have v final. This is 34.3 meters, if I remember correctly. Yes, it is. And then finally, I just want to see if you guys can actually see. Okay, then finally we can use this formula which states that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. Okay, that is what we can use to find the final velocity. We have this acceleration, it's 9.8. We have the distance, it's 34.3 meters. we have the initial velocity. It's 0. So let's plug it in. That is 0 squared plus 2 times 9,8 meters per second squared times the distance of, what's the distance? 34.3 meters. And that is meters per second squared. If you were to find the square root of it, okay, so let's leave it that. So this all, if you were to find the square root, v squared is equal to, not v squared, v final is then equal to the square root of 0 squared plus 2 times 9,8 times 34.3. And if you were to work it out, 0 squared, that's 2 times 9,8, that is 19.6 times 34. The square root of that gives you about 25,9. Is it 25 or 35? Let me just check. 25,9 meters per second. Okay, that is the speed, its final velocity. Okay, this is the final velocity of this stone while it's being thrown upwards. Now we want the impulse, and we've established that impulse is mass times the change in its velocity. The mass is 0.28 kilograms, while the change in velocity, the final velocity, is 25.9 minus 0. So your answer at the end, therefore, is 7.3 newtons per second. Okay, Newton second, not per second, Newton seconds. That is the impulse. Okay, that is the impulse. And remember, its impulse is, impulse is force times time. Therefore, its units will be Newton seconds. Okay, as it is here, 7.3, not 73, sorry. Erase this. 7.3 Newton seconds. That is the impulse being imparted to this rock. Let's go to question number 7. This is a very interesting problem. I like it. A 2,000, a 2,000, so a 2-ton truck, okay, 2,000 kilogram truck traveling at a speed of 6 meters per second. So it travels at a speed of 6 meters per second. This is the truck. It's traveling at 6 meters per second. It makes a 90-degree turn. So it's traveling this way, then it starts going this way. 90-degree turn in a time of 4 seconds. So the time it makes this turn is 4 seconds. 4.5, 4 seconds. So I'll just say time is 4 seconds, 4.0 seconds. My S keeps looking like a 4.0 seconds. And it merges from this turn with a speed of 4 meters per second. Now it actually has a new speed of 4 meters per second after it has taken that 90-degree turn. What is the magnitude of the force? What is the magnitude of the average resultant? Now you can't find instantaneous force because it's currently shifting. It is constantly shifting, but you can find the average resultant force. And for that, you can work out the impulse. So let's try and find the average force. Now, what do we need first? Okay, first, for the average force, the average resultant force. So let's find out the force. There is and what is the average resultant force of the truck? the resultant force. So first, let's find out the average force in the horizontal direction. So the average force is still number 7. The average force, we want to find the average force in the x direction. So the average force in the x direction is the change in the truck's momentum over the change in time, and that's the momentum in the x direction. Okay. Remember, this is still impulse. Change in momentum is the impulse. Now, what is the change in the momentum? That's the momentum initial, the final momentum minus the momentum initial. That is momentum final in the x direction. Momentum in the x direction, final, minus momentum in the x direction, initial, over the final time minus initial time. Okay. Now, if you were to substitute this even further, we know that momentum is mass times velocity. So we can just write mass times velocity final in the x direction, velocity in the x direction final, minus velocity in the x direction initial, over the change in time, over tf minus t initial. Okay, so that is how you will get your average force in the x direction. So let's see, if we were to substitute all these values in, let me see if I can still see them. Okay, I can still see the values. The mass of this truck is 2000. The final velocity, and here is where you actually need to use your logic thinking. Okay, the final velocity in this case, since it's making a 90-degree turn, it needs to stop. Okay, so the final velocity is going to be 0 in the x direction. It's not going to be moving in the x direction anymore. It's going to be moving in the y direction. Its initial velocity in the x direction was 6 meters per second. So we divide that by 4 seconds, and we get that this average velocity in the x direction is negative 3000 newtons. So the average velocity in the x direction is negative 3000 newtons. Okay, now what is the average velocity in the y direction? Same concept. Okay. So average velocity in the y direction, let me just write down the final formula. It's going to be still, it's going to be, we've already derived the formula, so it's going to be the mass multiplied by the final velocity in the y direction minus the final velocity, the initial velocity in the y direction, over the change in time. Okay, so the mass is 2000. The final velocity in the y direction is 4 meters. It comes out of the turn with 4 meters. Its initial velocity was 0 because initially it wasn't traveling in the y direction. So we divide then by 4 meters per second. That gives us 2000 times 4. So that's basically 2000 newtons is the average force in the y direction. Now we can write it down. The average force in the x direction, remember, is negative 3000 newtons. So the average force, so basically this is saying, this negative is saying that force was applied to stop the truck. So the force, because the force is opposite the direction of motion, original motion. Okay, so negative 3000, and its final force is positive 2000. Okay, so how do we get average velocity? Average force is then equal to the square root, that is just, of the force in the x direction squared plus the force in the y direction squared. This is the resultant force that we are getting, the resultant force, because we have the average, the force in the, let me just redraw it. The force is 3000 newtons in that direction, and then it is 2000 newtons in that direction. This is the force alone, okay, in the respective directions. So the resultant force would be pointing in this direction. That's the resultant force. We want that force. So the resultant force, average resultant force, is equal to square root of force in the x direction, negative 3,000 squared plus 2,000 squared. That gives us an answer of 3,600 newtons. Okay, and they only asked us for that. Obviously you can also go and then calculate the direction that this force is traveling, but suffice it to say you can write this as 3.6 kilonewtons, and that is what is the correct answer. Okay, so moving on, question number 8. Let's see question number 8. It's quite a challenging one, but this is why we give you the problems beforehand, or why we teach you to solve the problems in such a way that you will not get it wrong again. So a 3 kilogram stone is dropped from a 39.2 meter high building. Okay, so we drop the stone from the building, and then when the stone is falling 19.6 meters, the magnitude of the impulse it has received from the gravitational force is, so we drop a stone from a 39.2 meter building, and after it has fallen 19.6 meters, the impulse it has received from the gravitational force is. Okay, so firstly, let's find out what its final velocity is after traveling 19.6 meters. Okay, so it will be the initial velocity squared plus 2ax. We've used this formula before. So the initial velocity is dropped, so the initial velocity is 0 plus 2 times 9,8 times x. The distance is 19,6 meters. It's dropped. And then if we were to work this out, we will get that this is actually 19.6. This is 2 times 9,8, which is 19.6. And this is 19.6 squared. So V final is 19.6 squared, which means the final velocity is just 19.6. If you were to add this up, 0 squared plus 2 times 9,8 times 19.6, it will give you 19.6 squared. Right? Because 2 times 9,8 is 19.6, and then 19.6 times 19.6 is 19.6 squared. And then if you remove the squares or square on both sides, your final velocity is 19.6 meters per second. Okay. Now we have learned that momentum, or the impulse, change in momentum, impulse is equal to mass times the change in the velocity. And we have the mass. It is a 3 kilogram stone. It's a heavy stone, quite. And then we have the change in velocity. Its final velocity is 19.6 meters per second, while its initial velocity is 0 meters per second. It's dropped. And if we were to work that out, our impulse would be 58,8 Newton seconds. That is the impulse. Okay, that is the impulse. So, or other word, the change in the momentum. Okay, that's the magnitude of the impulse it has received, or change in momentum. And as you can see, these problems are reasonably quick to solve. Question 9 is a really good problem due to the fact that it deals with collisions. Okay? A 5 kilogram mass with an initial velocity of 4 meters per second east collides with a 4 kilogram mass with an initial velocity of 3 meters per second west. Okay? After the collision, the 5 kilogram mass has a velocity of 1.2 meters south, what's the magnitude of the velocity of the 4 kilogram mass after the collision? Okay, so this is a collision problem. Let's calculate the initial velocity of each of these blocks in the x direction and then the initial velocity or the momentum. Let's calculate the initial momentums. I think that would be easier or a good place to start. So the initial velocity in the x direction is equal to 5 times the 5 kilogram mass, and it has a speed of 4 meters per second, and then plus, that's the initial velocity in the x direction, plus we have that the 4 kilogram mass is traveling in this direction, in the western direction, so its velocity is negative, so it's 3 meters per second. That gives you 5 times 4, which is 20, minus 4 times 3 is 8. So 8 meters per second, 8 kilogram. Let me see if that fits in there. So it's 8 kilogram meter per second. So that is the initial velocity in the x direction. Let's look at the initial velocity in the y direction. There is initially no velocity in the y direction. So why do we say the initial velocity in the y direction? Why do we say there's initially no velocity? Let's read the question. It says that because none of these blocks are traveling initially in the y direction, so there is no momentum for either of them in the y direction. So we continue. We have the initial velocity momentum in the x direction is 8 kilogram meters per second. Initial velocity in the y direction is 0 meters per second. Now let's go for the final velocity in the y direction. That's equal to the initial velocity of the just look at this. Okay, so we have one block after the collision. The 5 kilogram mass has a velocity of 1.2 meters south. So 1.2 meters south. What is the magnitude of the velocity of a 4 kilogram block after? So first let's look at the velocity in, well, not the velocity, I keep saying the velocity, the momentum in the y direction after the final. So the momentum in the y direction final, so that will be the final momentum in the y direction is going to be the momentum from the 5 kilogram block in the y direction plus the momentum of the 4 kilogram block finally in the y direction, and that's going to be equal to five kilogram. It has a velocity, so it's going to be 5. Let me just erase that and write it underneath. So the 5 kilogram block in the y direction in the final is going to be 5 kilograms multiplied by 1,2. No, sorry, it is the 4 kilogram block. There's the 4 kilogram block there. So this is for the 4 kilogram block. I'm going to write it this way. So it's going to be 4 multiplied by 1,2. That's the momentum final. And it's going to be south. So let's put a negative there. It's heading south. What is the magnitude of the velocity of the 4 kilogram mass after the collision? Got to check something. We don't know what the 4 kilogram mass is after the collection, so that is what we want. Oh, I made a mistake here. So P final in the y direction, correct? We have the 5 kilogram mass. That's 4 kilogram. This is wrong here, and I'm wondering why that is the mistake. Now, the momentum of the 5 kilogram block. Okay. The 5 kilogram block, where is it there? It is 3 meters per second. Now it is 1.2 meters per second south. Okay. We have no idea what the momentum is for the final momentum for the 4 kilogram block, the final momentum in the y direction for the 4 kilogram block. Remember, this is final for the y block, but for the 5 kilogram block, its final momentum is, it's going downwards, so it's 6 kilogram. It's 5 times 1,2. Okay, 1/5 of 5 is 1, so 5 times 1 plus 5 times 1/5 of it is 6 kilograms. Let me write it this way. It's 5 times 1,2. Therefore, it is, but it is downwards. I just switched this all around. So it's -6 kilogram meter per second. And then plus, we don't know what the final momentum is for the 4 kilogram. This is for the 5 kilogram block here. For the 4 kilogram block, we don't know what that is. But what we do know is that the sum of those two should be equal to 0. Okay? The sum of these two should be equal to 0. Reason is it is a elastic collision. Okay, so it's an elastic collision. So what is the momentum of the block final of the 4 kilogram block? Its momentum, therefore, if you were to take it over, its momentum is going to be equal to 6 kilogram meter per second. Okay, so that is the momentum of the 4 kilogram block. It's going to be 6 kilogram meter per second. So now we have the final momentum of the block in the y direction and the final momentum of the block in the x direction, in the y direction. sorry, this is just in the y direction, the final momentum of both blocks in the y direction, but now we need the final momentum of the block in the x direction, final in the x direction. Now its initial momentum in the x direction is 8 kilogram meters per second, and then we have that its initial momentum, or its final momentum in the x direction, is 0 for the 5 kilogram block because it's moving south, it's moving in the y direction, so it has no x component, plus the momentum in the x direction of the 4 kilogram block. We've established 4 kilogram block. 4 kilogram block. We've established this is the momentum for the 4 kilogram block, because that's a 5 kilogram block. It's moving only in the vertical direction. Then for the 4 kilogram block in the x direction, its momentum is equal to P4. Therefore, the 4 kilogram block's momentum is equal to 8. Okay, so the final momentum is 8. So this is what's happening. The final momentum is 8 kilograms in that direction, and then 6 kilograms in that direction for the 4 kilogram mass. This is its initial velocity, and this is its final velocity, final momentum. Initial momentum, final momentum. Its momentum, its initial momentum is 8 kilograms this direction. Its initial momentum in the y direction is, or its final momentum in the y, its final momentum in the x direction is 8, and its final momentum in the y direction is 6. Now if we were to find the magnitude of the resultant momentum, it's going to be 8 squared plus 6 squared. Hence we're going to get that the resultant moment is 10 kilograms per meters squared. That is the magnitude of the momentum of the 4 kilogram block. Remember, we were working out its y momentum in the y direction is 6 kilograms. Its final momentum in the y direction is 6 kilograms, while its momentum in the x direction, its final momentum is 8 kilograms. And then we have that impulse is equal to mass times change in velocity. So the change in the velocity is what we want. It starts from 0, so we want the change in velocity. So the change in velocity is equal to impulse over mass for the 4 kilogram block. Its impulse, or its momentum, its net momentum is 10 kilograms kilogram meter per second, and then its mass is 4 kilograms. It's only for the 4 kilogram block. Remember, this is its mass, it's momentum. So the momentum over mass is equal to 2.5 is the change in the speed. So 2.5 is a change in the velocity. However, we do know that in this block is moving from a collision, which means its initial velocity then was 0. So its final velocity is 2.5 meters per second. Okay. Now, question number 10. Sorry for that big mix up in the beginning. Question 10, we have that a car A rear ends car B, which has twice the mass of A. Okay? So we have two cars. Okay, car A bumps into car B, and car B has twice the mass of car A on an icy road at a speed low enough so that the collision is essentially elastic. Okay, so car B is stopped at a light when it is struck. Has stopped at a light. So car B's initial momentum. Car A has a mass of m and a speed of v before the collision. After the collision, what happens? Okay. Now the momentum of car B therefore is 4 times as great in magnitude as is that of car A. The reason being, car B is twice the mass of car A. So let's say the momentum of car A. Okay, let's work it out. Okay, by the way, I clicked the wrong one here. Car A, let's say car A. Car A, its momentum is mass times velocity. That's car A. Now car B, its mass is twice that of the mass of car A. And since car A rear ends car B, and car B is actually starting from 0, and the collision is essentially elastic. Car B starts from 0, is twice the mass car B, and since it was originally uh, still on the road, it will have, it was stopped at the red light when it was struck, and it starts to move, which means, and then car B has a twice the mass of A. Car B moves, that all the momentum is elastic, so it is transferred, the speed is transferred. I'm not explaining that good enough. Car A rear ends car B. Okay, so we have car A is moving at a speed V, and it rear ends car A with mass M, and it with moving at speed V before the collision bangs into car A, which is standing still at the stoplight. It has a mass M before at a speed V before the collision. That's car A. Now after the collision, what is the momentum of car A and what is the momentum of car B? So the answer is that car A, the momentum of B is 4 times as great in magnitude as that of car A. Okay, so what is the momentum of car A? That is for after the collision. Okay, what is the momentum of car A after this collision? Okay, so they bump into each other, so the momentum, the law of conservation of momentum says that car A has an initial momentum, car A initial momentum of mass times velocity, car B initial velocity, this is how I wanted to explain it, initial velocity of, it has twice its mass, but it is standing at the red light, so it has zero velocity, it has zero momentum, so its momentum is 0. Okay, now they bump into each other. Okay. Now car A, what is its new velocity? Okay, what is its new velocity? So let's see, it's an elastic collision, so momentum is conserved. Still has the same mass, but its velocity now has to be the same. Okay, it now has the same velocity. Let me get back to you on this one, but the answer is D. Okay, the answer is D. I'm going to say goodbye for now, and I will see you in the next one. Okay, uh let me just check, let me give me a pause for a second. I want to work this out. because there is something that I'm not unsure about here, and I'm going to work it out quickly. Just I'm going to switch quickly to, let me just see here. Okay, guys, I've given you answer, but I'm going to solve this one. Realize I have made a mistake here. I did get the correct answer, but the method I used is wrong. But thank you. Not wrong. The answer is the momentum of car B is 4 times as great. It is great in magnitude as that of car A. Okay, that is the correct answer. But I have messed up my approach to my answer here, and I tried to do it quickly, but I now realize I need to take into account the kinetic energy of each of these blocks, and I did not do that. I just took their speeds. Okay, I did it generically, but I will come back to those of you who actually want me to do the problem. I'm going to go do it right now after the session, and then I will, those of you that want it, I will post it. I will send you the correct answer. Okay. Okay, guys, I did figure it out, but the thing I left out in my calculation, okay, I did not I used another method which is not taught by you guys. I used like a, what do you call this? The kinetic energy. Let me say just, I did not include the kinetic energy. I still got the correct answer, but it was a haphazard way of doing things, and I do not want to end it like that. So I will do the problem whole, complete, and then those of you who want the answers, please send me an email so I can drop it. It's going to take too long now for me to figure it out, or I can do it. Let me just see if I really have time. Doesn't seem like I have time because I need to be at another place. I need to go do a practical. But suffice it to say, that it is doable, but I just made a slight miscalculation for something, and I will get back to you on that problem. Okay, thank you very much for listening, and I will see you